thing and the first method of factoring that we have is to find a greatest common factor for two terms. And anytime you are asked to factor something, that is the first thing you're going to look for, because a lot of times if you do that first, it makes the other methods much, much easier. Okay? But first we need to understand what are we doing when we're factoring something. So let's go back to 4th grade when we learned our terminology. We had addition problems where the answer was called the sum, and the two numbers being added were called the what? Do y'all remember? The add-ins. And then in a subtraction problem, your answer was the difference, and the two numbers were called the minuend and the subtrahend. Y'all remember that? Wow. I remember that. Okay. And I'm old. Yeah, but I don't have to teach that part. And when you were dealing with multiplication, factors, right? The answer was the product, but the two numbers being multiplied were called the factors. So when we are factoring something, we are starting with a product, and we're trying to break it down into the factors that gave us that product. Now, these are two numbers. I'm using numbers only so that you can see exactly what we're doing and why we're doing it, or how it is the same thing. What is the answer to 25 plus 10? 35. Okay. Now, when we're factoring, and you're not going to see the culmination of this whole thing until probably Friday, but the purpose of factoring is to be able to separate groups so that when you have to divide and cancel, you can correctly do that. All right? So, but right now we're just learning how do we do it. If I asked you to factor this sum, we're going to pretend we could not really add 25 and 10. We're going to pretend they were not like terms. So we're trying to take it and pull things out of it that they have in common with each other. So tell me, what are factors of 25? What two numbers could I multiply and get 25? 5 and 5, right? Well, we're going to do prime factors other than 1. Okay. And what are factors of 10? 5 and 2. Now, would everyone agree that this is still, when you put it all together, 35? Yes, so I haven't changed the problem at all. I've just changed the looks of the problem. Now, to factor out or remove a common factor, I need to identify in both of these groups, which factors do they have in common? They have a 5 in common with each other, correct? To factor out means to divide by. Now the question is this. This one has 2 5s. I could divide by 2 5s and still have a whole number, correct? But could I divide this number by 2 5s? Because it only has 1. So the greatest common factor is the most that they both have. And they both have 1 5. And that's the most that they both have. So the greatest common factor in this case is 5. Now my job is to tell you what's left. Well, if I'm factoring out, it means that I'm dividing each thing by 5. Well, if I divide this by 5, what's left? And if I divide the other one by 5, I have 2 left. Now, would you still agree that this problem at the very bottom works out to be 35? Yes, because 5 plus 2 is 7, and 7 times 5 is 35. So the result is still the same, okay? All I'm doing is I'm pulling out a common factor in order to separate this into whatever products would give me the original problem. Now, let's use letters. Okay, last one was numbers because we could actually see that it was 35. In this case, we cannot add these two things together. These are unlike terms. You can't put them together. If I asked you to factor to factor this expression, I'm asking you to break it down into a product of its primes. All right? So what I'm going to do is I have two terms here, and I'm going to identify which factors they have in common with each other. When you're dealing with letters, it's what letters do they both have? They both have X's and they both have Y's. But I can only pull out what they both have. Do they both have at least 2 X's? Do they both have 3? No. So X squared is the greatest common factor. What about Y's? Y to the first power. Because the first term only has 1, and I can't take more than it has. All right, well, if I were to factor this out of the expression, it means I'm dividing each term by x squared y. Well, what's x squared y divided by x squared y? 1. And you have to put the 1, because 1 does exist. There's just no letters left. Bring down your plus sign. X cubed divided by x squared is what? And y squared divided by y is y. This is a product of its prime factors. Now, you can check yourself from this point. How do you think you can check yourself? Multiply it out. Redistribute and make sure this is what you get. Because it's supposed to be the same thing. You're not supposed to have a brand new problem. It's supposed to be the same thing. X squared y times 1 is this. X squared y times xy is x cubed y squared. Okay, you've simply divided it into its factors. If we add numbers in front, the number part's easy. You're basically asking yourself what goes into 10 and 5. What's the biggest number that goes into 10 and 5? 5. Now for the letters, I need only letters that are common to both. Which letters? A squared, B cubed. Very good. Take the smallest exponent. And so, in order to figure out what's left in the problem, I'm going to divide both of those terms by 5, a squared, b cubed. Well, what do I have left when I divide this term by 5a squared b cubed? 2. That's all I have left.
What'd you do?
I'm factoring this out of this, which means I'm dividing by this. So 10 divided by 5 is 2. A squared divided by a squared cancels the a's. And b squared cubed divided by b cubed cancels the b's. Okay? Look, this times 2 is this. Bring down your minus sign. When you divide this term by 5, what do you get? When you divide a cubed by a squared, b4 by b cubed, c squared, and close your parentheses. That is the product of the factors that gave you that original expression. And like I said earlier, you can check yourself by distributing it back into the parentheses to make sure that all your numbers and your exponents and everything work out. Okay? If there are 3 terms involved, you just have 3 terms to look at now. What's in common with all 3? I want you guys to figure this out. Find your greatest common factor and show what's left.